This is my first lecture on NPTEL TA ship of Nonlinear Vibration ME 56. Here I had recorded this video just 2 hours back, but the voice actually I couldn't attach the voice at that time, so I am doing the audio again. So hence there will be a non-syncing of voice and the image. This will be 2-hour long session, so don't worry, it's all planned out. And what we will do is I have some surprise for you, and this surprise is why we will be sitting for 2 hours, and let's make it more interesting, that we can interact with each other and you can ask doubt anytime. So hi, again my introduction. I am Anshuman Mehta, PMRF PhD scholar in Department of Aerospace Engineering, IIT Bombay. So in PMRF NPTEL TA scheme, what I have to do is I have to take an interactive session. Hence, so I will be just narrating what is happening here. Because of this non-sync of the audio, I think I am telling about the responsibility. I work in periodic systems, so it's part of nonlinear systems, and I look into aerovelocity. In my area is aeroservovelocity. This won't be fair because at that time I had talked a lot, but now by looking at myself I cannot guess what I am saying. I am saying. Also, there was a conversation with students, as you can see. So yeah, the question they have asked, I had list down of that because I have written those thing. So okay, so I have started. So I have a unique way of teaching. I always ask myself that how can I make subject more exciting for students. So this gave me the idea of capturing the students' attention by using comic books, the comic book heroes, to explicate the basic principle of mechanics and dynamics. So my idea was just that, to make it more interesting, because students find it much more interesting to determine Spider-Man's centripetal acceleration as he swings on the webbing, and to talk about tensile strength of a real spider's web. So as compared to real spider's web, what could be the Spider-Man web tension? Then also to describe the weight on the end of the twirling string. So this is just an example. We can also take an example of what will the weight of Thor's hammer if nobody can lift it. So what is the worthiness of it? So hence getting into these things. So comics as an art can generally be seen in daily newspapers that are typically colorful or black and white with words and images. So you have seen in the comic there would be 3 frame comics and it would tell a story. So that story, it could have humor, it could be emotional, it could be anything. So it is generally underrated as a educational tool, and it is frequently seen as nothing more than a pastime. But studies in different fields have shown that it can be more than just a mere pastime. how can I say this? Because the world is not all about infographics now, and you can see that nobody is going with the boring slides and they want something extra. So this is also in that path, to so that people can get attention, and they can seek or also understand without getting bored. So in fact, there is a growing number of studies on the use of comics as a tool in the field of medicine, communication, art, business, and education. So this is my first comic series, and I have thought about this from past year. I will do something like this. So this NPTEL also gave me a nice opportunity in which I have to take 2-hour class now. So I have to prepare something, and so that people don't get bored and people can watch this. So I hope to attract a wide variety of students, including many who are not comic book fan also. So the person Durga Prasad, he is not keen into Batman, but then also I will explain the intricacy of the Batman characters, so that the final part in which I can explain why those characters, the theory which we wanted to learn in this subject. The thing is all about enjoyment, and it's for those who have enjoyed physics in high school and they have visualized the monkeys in the S.C. Verma problem, and they have, this is all about entertainment here. So in entertaining way, if you are learning something, that's what I need. So we have I had discussed then a lot of thing by which graphic arts is very useful, and how animation and the thing by which we can make the presentation visually appealing is what is the next age presentations look like. Comic books are something which I have always cherished from my past. So in my childhood, like my mother used to scold me when I was reading comics. So now see, I am I am teaching a subject using comics. So that's irony. But the thing is, comic book, if it's in a right subject, it can have a very good impact, and it also goes the other way around, in which if some bad comics is there and a student of very less age, or they cannot understand it, so that have a great bad impact. Okay, so for this comics I wanted to put a disclaimers and everything, so that we can solve our real problems, which are the course problems. So before moving forward, let me take some series of tests, since you are part of this comics. So I have made this comics in such a way that you are playing a character. Okay, so now this is my part, that let me check whether you are worthy of this. So worthy of reading this comics or moving forward in the class. So as you have guessed, like I have just put assignment 0 problems in form of a story. So my prime work is telling stories, just that I am teaching the subject like that. Okay, so we will start. Yes. So you are a Lucius Fox, business manager at Wayne Enterprise, and your computer is checking you for human, so it asks a series of questions to log into your mail. Now, one who don't know about anything, so Gotham City is a fictional city, and in that Wayne Enterprises is a multi-billion company whose you are manager of it, a business manager, and you are also very good at technological things. So by training you are an engineer, and your computer is now checking for whether you are human or not. So that's a silly thing. So yes, so you just need to log into the mail. So the computer asks you simple questions. So this is a question, because MATLAB would be our primary software in which you would be doing a lot of numerical things. So hence all those questions are regarding MATLAB, so that you are worthy of using the MATLAB. So in the command prompt of MATLAB, if you write a equal to 5 and press enter, the output will be dash, and if you write a equal to 5 semicolon and press enter, the output will be dash. So I have asked this question and I got the correct reply, that a equal to 5, and there will be no display on the second command, because the semicolon kind of it doesn't print things, so like it will store but not print. So the answer is A. So we successfully had done the first question. Now moving to the second question. I don't know what I am explaining right now. Okay, moving to the second question. So if A is equal to 2, 5, 7, 3 a matrix, and similarly B is another matrix 3, 2, 5, 8, and in MATLAB you put if C is equal to A plus minus B, then C bracket 1 comma 2 bracket close will be how much? So this is just to get you familiarized with the matrix notation as well as MATLAB notation. So answer is 3. How did we get to that? Is we define matrix in such a way that the positions and are something of this orientation 1 1 1 2 2 1 2 2, and the thing which you are asking is the value of C at 1 comma 2. So at this point, so if we do 5 plus minus 2, we will get 3. So our answer is 3. Now moving on to the question number 3, in which A is equal to same, the matrix are same, A and B, and if you want to find C is equal to A dot star B, there is a dot, okay, and then C 1 comma 2 is again how much? So there is something dot. So any MATLAB user would be knowing that dot is for element wise computation. So if we are putting dot in front of some operation, it will do it element wise. So element wise means like it will take 1 comma 2 of matrix A, then 1 comma 2 of matrix B, that is 5 into it will multiply those. So answer will be 10. So congratulations, you have successfully logged into the Wayne Enterprise computers network, and you have a mail waiting from your boss, Mr. Bruce Wayne. He is the owner of Wayne Enterprises. So let me explain about that. So Bruce Wayne is son of Thomas Wayne and Martha Wayne, and they are billionaires, and so they were killed in when Bruce was very young, and now he is taking care of the enterprise. So this is your screen, and there is one unread mail by Mr. Bruce Wayne, and what does it contain is that it gives a problem statement by Mr. Bruce Wayne. He requires a custom made motorcycle that has built-in guns. Mr. Wayne needed it for extreme rock motorcycling, and he needed it in black. So there are a lot of things into it. So first of all, he needs custom made motorcycle, like we have to make adjustment to a existing motorcycle, and so that it can have guns. Like why do we need gun? Because he is saying that he needed for extreme rock motorcycling. Maybe he need to destroy some rocks and then he to go into that. So, and also he need in black. Now that much was in the mail. Now we will do some literature survey. We found out that we have a prototype in Wayne Enterprises, but it had two missing parts. One missing part is the shock absorber, by the gun. Like if we have a gun, so there will be a recoil shock, and that we have to find out ki how much V naught initial velocity it can handle following a displacement curve, as it will be shown just in a bit. Now second, the damped period of vibration is to be 2 seconds. Like it should be taking 2 seconds for the very comfort zone that it should damp out. Now also the amplitude x1 is to be reduced to 1/4 of the 1/2 cycle. That means x 1.5 should be equal to 1/4 of x1. What does that mean? We will be explaining in figure. So what does a underdamped shock absorber is something which absorbs the shock of some disturbing element. In our case, it is not the bump of the road, it is recoil of this gun which is installed in front of this tire, inside of this tire. So this is our primary aim, and we have to look in conjunction of these two components, like the shock absorber as well as this gun, like how much we can be practical about it. So this is like we have a scenario and we will be finding the solution out of it. So everything is given, even the motorcycle mass is also given, which is equivalent to 200 kg. Now what we will do, we will abstract this motorcycle into something which we know. So right now it is just bunch of pictures, but we wanted to make into a meaningful problem. And also we will first write what is given and then we will move forward. So the figure come out to be this. That's what we can abstract from this situation. Let's assume this m be the mass of this motorcycle and k be the stiffness of the shock absorber, c be the damping constant of this shock absorber. We need to find all these things because mass is given. We have to find k and c, and also we have to find one more thing, that if maximum displacement is equal to 250 mm of this vehicle, what does that mean is you can see that whole body is moving, like it is a multi-body problem, and there are 2 points which can intersect if the shock absorber is compressed to its limit. So hence we have that maximum deflection with factor of safety as 250 mm. We need to find out how much recoil velocity it can handle. So this V naught is initial vertical velocity due to the gun mounted. Okay, so this gun mounting, how much it can take, so that we can install much better gun. And also for gun part, this is the second part, like the critically damped recoil damper, but right now our problem is just underdamped system. So by we can see that x1.5 is equal to 1/4 of x1. So this gives us a meaningful relationship between x1 and x1.5. So if x1 is first deflection in one direction, the x1.5 is the deflection in the other direction. So our task is to find the maximum velocity it can withstand, recoil velocity, and also find stiffness and damping constant. So we will start with what we know given. So x 1.5 is equal to x1 by 4. So in the same way we can also write x2 is equal to x 1.5 by 4. Which again we can write by using the first statement as x1 by 16. So it gives a relationship between x2 and x1. Now we can define logarithmic decrement delta is equal to ln x1 by x2, which will be equivalent to ln 16, which we can actually calculate it. So I have used my calculator to calculate it, which comes out to be I am fast. So 2.7726. So this is value of ln 16 I found over the calculator. So delta is equal to 2. There is another relationship between logarithmic decrement and zeta, or in our case called damping coefficient. So delta is equal to 2 pi zeta by under square 1 minus zeta square. So this is equal to 2.7726. Now this is the quadratic relation. So we can find its two root. We have to solve it. So it's quadratic equation in zeta. So we come out to be, like, we squaring both sides, we come out to be 4 pi square zeta square is equal to 2.7726 square in bracket 1 minus zeta square. Taking the zeta square term in one side, we can write like this. I think there is a problem in which this 4 pi zeta square, instead of 4 pi zeta square, the zeta square won't be there because we already taken it common. So zeta square can be written as 2.7726 square divided by 4 pi square plus 2.7726 square. So which comes out to be, I am again using calculator, 0.16298. Now zeta is equal to 0.4037, which my calculator gave. By taking under root, there will be plus and minus value, but we will be taking positive values. Okay, so what does this give us is damping coefficient Yes, so this is our problem statement. Find the necessary stiffness and damping constant of shock absorber. Also find the minimum initial velocity that leads to maximum displacement of 250 mm. So this 250 mm I will show in the diagram what does that mean, but for now we have find out a damping coefficient zeta. So another data which is given is the damp period of vibration is 2 seconds. So damp period means from x1 to x2 omega which is related to omega d, because tau d the damp time is equal to 2 pi by omega d. So data 2 has two information. First is x1 is to be reduced to 1/4 of in the 1/2 cycle, and another is damp period is 2 seconds. So we will now use damp period is equal to 2 seconds. So we can write the relationship 2 pi by omega d is equal to 2 seconds, which gives us omega d equal to pi. Now omega d we know is omega n under root 1 minus zeta square is equal to pi. So this gives us omega n value, because we know zeta as well as pi, which comes out to be I am again calculating it using calculator. Which comes out to be 3.4338 radian per second. Okay, so we have found omega n. Now we need to find k, c and maximum velocity which it can handle. So let's first write the relationship of critical damping. Critical damping constant, also known as Cc, so that is equal to 2m omega n. M we know as 200 kg, so hence 2 into 200 kg into omega n, which we just found out is 3.4338 radian per second. So our unit of Cc is of damping constant, Newton second per meter, and the whole expression come out to be 1373.54 Newton second per meter. Now we will move on and see damping constant, which is C is equal to zeta into Cc. So this is what is asked in the problem statement C. So the solution is C is equal to 554.498 Newton second per meter. So this gives us first part of first solution. Now you have to find K. So for k, we know that omega n is equal to under root k by m. So k is equal to m omega n square is equal to 2358.2652 Newton per meter. So we got A.1 solution. Now we will be solving for A.2, which is also find maximum initial velocity that leads to maximum displacement of 250 mm. So it's given that maximum displacement it can handle up is 250 mm. Now I am showing you like what this maximum displacement means. So as you can see here, the shock absorber, at one of the end of the shock absorber there is this point, the pink point which I have just marked, and in the other end of the shock absorber there is a tire. So it has, if the shock absorber compressed to the limit, those two can have interference, and that could be great cause of accident to kill Bruce Wayne, that we don't want. So hence we know that while having a factor of safety that is 250 mm. Now we wanted to maximize the gun potential. So hence what we are doing is we will be finding response. Now response of our underdamped system can be written as xt is equal to e power zeta omega nt bracket start x naught cos omega dt plus x dot naught plus zeta x omega zeta omega n x naught by omega d sin omega d t. So this is response of underdamped system having x naught as initial condition and x dot naught, which will be representing in v naught from now onwards, that we have to find. So we have to find v naught so that x t max is 250 mm. So this can be rearranged since x naught is 0 as v naught by omega d e power zeta omega n t sin omega dt. Okay, and at this point another student joined. So there was interesting question the way. Yeah, so now to find maximum of x, which is a function of t, we have to find its derivative and equate it to 0. So it's a maximum minimum principle in which if you have to find a maximum of a function, we differentiate it and put it as 0. So we will be doing that here. So to find maximum displacement, which is already given 250 mm, you have to find this v naught. So I am explaining the interference, that there shouldn't be any interference, so hence this is the ultimate maximum displacement. We cannot go more than that. If we go more than that, we will have interference. So xt, it will be maximum when x dot t is equal to 0. Now x dot t we can write by differentiating xt, which will be v naught by omega d e power zeta omega n t and bracket open minus zeta omega n sin omega dt plus omega d cos omega dt. Now we have to put this as 0. We can get the expression of velocity by differentiating response. So by differentiating so this cannot be 0, so hence we are moving on to the whatever is there in the bracket term, so that should be 0. So I will just copy this term here and put this equal to 0. Now what is variable here is time, so we can know at what time the we will gain maximum displacement. So we can modify it as tan omega dt is equal to omega d by zeta omega n, which again will be equivalent to under root 1 minus zeta square by zeta. So converting all t equal to t1, we get t1 is equal to 0.367 by calculator, 0.367 second. So at this time we will get maximum displacement, which is equal to 250 mm. So in the velocity, in the displacement term, if we put t is equal to t1, we can get the value of v naught. So maximum displacement at t equal to t1 in terms of v naught is equal to 250 mm. So this was given. So x of t1 is equal to 250 into 10 to the power 3 minus 3 meter. So we will just put all the values. And we will get this sin omega d t1. So here v naught is equal to we will just put everything in the calculator. So v naught comes out to be 1.429 meter per second. So this solves our A part, in which underdamped system, shock absorber system, you have to find K, C and also V naught. So let's revise the question again, because you would be using to get the second part. So he needed something for which has build up current and also the shock absorber. So the second thing, which there are two parts missing, right? So one is underdamped shock absorber of motorcycle. Okay, I think Nazir Basim is joined. Okay, I had asked some question. I don't recollect what I asked then. So maybe I was explaining about recoil. So every gun or any ballistic thing which project things will have a recoil velocity, and that recoil velocity is again a disturbing force. So when we look at the comfort of some, let's say some commercial aircraft, then we look at underdamped system, because we have to we don't have to come to rest at that point, like to in the least time. We can have our own comfort zone in which that time is of optimal value where the comfort is defined. But for something we have to, okay, we can talk about this in the question asked. So right now what happened that I had written the solution on the question itself, so I am rubbing. First I have made a copy of the solution. Now I am rubbing it so that the question can be revealed. So this I think I have to do it less next time, the revelation kind of thing. Okay, so next question is the second part which we need is a gun barrel or gun. So it should be critically damped recoil mechanism for built-in gun. So a built-in gun is shown as in the blue color. Now when the gun is fired, high pressure gas accelerates the bullet inside the barrel to a very high velocity. The reaction force pushes the gun barrel in the direction opposite that of the projectile. Since it is desirable to bring the gun barrel to rest in the shortest time without oscillation, it is made to translate backward against a critically damped spring damper system called recoil mechanism. So this is very important, that here time is of essence and we have to bring the gun barrel to rest in shortest time without oscillation. So the shortest time without oscillation is something where critically damped systems are more designed, and so recoil mechanism generally have this critically damped system. So for our current problem, we are taking mass of the gun as 50 kg with the recoil spring of stiffness as 1000 Newton per meter, and also the data is given that the gun recoils 0.4 mm upon firing. What you have to find out is the critical damping coefficient of the damper, the initial recoil velocity of the gun, and the time taken by the gun to return to the position 0.1 meter from its initial position. So in a gun, shortest time is why it's required is in military application mostly, because let's say if something is recoiling in very like it taking more time for recoiling, so it cannot fire the next missile, right? So for example, if a bullet, if a gun is firing a bullet at, let's say, 5 bullets per let's say minute, okay, so if a missile is being fired at 5 missiles per minute, and if recoil time is reduced to lesser time, let's say 1 second, okay, so we can actually fire 60 missiles instead of 5 missiles. So that is the thing in which the firing rate of a ballistic equipment have recoil mechanism such that it's a critically damped. So at this point, I think a question was asked. So Durga Prasad asked, like, why can you give me an example of underdamped system, undamped system, and critically damped system? Okay, we'll come to that. Before that, we will start the question. We will first write whatever is given. So K is given and M is given. So we can find out the undamped natural frequency. To find this undamped natural frequency, we can, okay, so the question was asked of practical example of underdamped system. Undamped system means like there is no damping, but in reality everything has a damping. So the example of underdamping system, critical damping system. Now the question was, this whole problem was designed with respect to this problem only. Like I was feeling that people should ask this question because these questions are asked in the interviews. That can you give me a practical example of underdamping system, critical damping system, overdamping system? So I only know one of each, so we can define that. But there was another question asked by Nazir, by which we got another examples also. So first let's see this. So underdamping system is always talked about in terms of comfort. So if we have some vehicle which needs comfort, so let's talk about luxury cars. So in luxury cars, if it is a rough road, so some such damping system should be there which kind of take its own time and it doesn't jump off, so that it doesn't at kind of come to rest quickly. So because that will produce a jerk and that will give us lot of G's of to handle. So hence the shock absorber of luxury cars have underdamping system, like it slows down the damping in such a way that there is no jerk. Now next, so if we look at the graph, underdamping system looks something like this, like the amplitude reduces and finally it goes to rest. The critically damped system and overdamped system have similar kind of structure because it couldn't go a single vibration, right? So what is difference between two? That is the most important question asked in the by the interviewers that give us an example of critically damped and give us example of over damped. Now over damped is something like our door not stopper, door which door closer or door damper, one which is in our lab, like in which kind of protect the system, like the doors to strike at the. So hence what we do is we put a door damper so it can come slowly to halt. We doesn't look at the door closing, like it will close or not, at how many time it will close. It's just that it should close after some time. But what if time is of essence here? So right now door damper doesn't need time essence, but what if we need to conserve some quantity in the rooms? For example, the AC is there or something is there, so we need to we want to shut the door as fast as it can without any oscillation. So that is where critically damping come into the picture. So what one can think about is recoil mechanism, which is critically damping. Now you can see if there is I am showing the working of a gun, and also I am explaining the firing rate, how much firing it will do. So we can have much higher firing rate if we have lower recoil time. So it's not like if you will have one more recoil time, so then if we fire in that recoil time, we will be going away from the accuracy. So that's what happened to a machine gun. If a machine gun which is not properly recoiled, it goes and shoot into very different direction. Okay, that's what I was explaining you. So in this problem we are taking care of gun recoil. So we have to design a critically damped system. So first we will find omega n, which will be equal to under root k by m. So at this point we can see a doubt in chat which was asked by Nazir. I will be looking it at a little bit later. Okay, so given our mass is equal to 50 kg and k is equal to 1000 Newton per meter, so critically damped system C can be find out is equal to 2m omega n, which is equal to 44.721, sorry, which is equal to 447.21 radian Newton second per meter. And also we had made a mistake in finding omega n, so it should be 4.4. At this point another student joined. Yes, so it should be 4.4721 radian per second, and critically damping is 100 times of it because mass is 50. So it should be 2 times 50 100. So at this point I looked at the chat and I found out a question. Also I was explaining to whoever newly joined that this will be recorded and you can watch it on YouTube, which I will be uploading next. So in chat the question was, sir, what about cruise control mechanism, and do we have to design according to the critical damping systems? So cruise control is a nice topic in which first we will define a steady state. So let's say this is our steady state, and whatever perturbation will happen because of the gust or any maneuver which we are doing, we will lose that steady state and we will come to a new unstable regime. But we can come back to the stable regime, but the essence of time is here again important, because if we come quickly back we will have a reaction jerk, but if we come slowly it means comfort. So again it comes with the comfort and the time, like less time. So again we can give example of commercial aircraft. In those it is moreover under damp system, like slowly it will damp out, so that whenever you are feeling any gust it doesn't act accordingly. But in the military aircraft you need accuracy, so hence it should come as soon as, so hence the personnel are also trained to encounter different G's, so that is where the firing of the missiles in the aircraft is of more importance, hence comfort is of less importance. So we can write that in cruise control mechanism, in the case of military aircraft, we can look at the critically damped. Apart from that, we don't need as per critically damped, it should be just underdamped so that the comfort is maintained. Now the question is why critically damped system have least time, is because of the fact that it is at the optimized time where the damping is being done, and this is all in the linear regime. So we'll carry on with the question, in which responses of critically damped system can be written as in this form: xt is equal to c1 plus c2t e minus omega n t, where c1 is equal to x naught and c2 is equal to x naught dot plus omega n x naught. The time t1, so it's again the same question as the previous part, like we can find that t1 at which xt reaches its maximum, which is given in our problem. We have to find t1 at which xt reaches maximum, which can be obtained using x dot t is equal to 0. Now c2 e minus omega n t minus omega n bracket c1 plus c2, so this is x dot t what we are finding, this should be equal to 0, so which will give us t1 as 1 by omega n minus c1 by c2. Now regarding the initial conditions, we can easily note that x naught is 0. So it's like we are firing a weapon, it starts from 0 x naught, and but it will gain x dot naught, like v naught will be there. By the way, we are using the same expression c k x dot v dot but it's different from the previous question, so don't confuse. So hence in this case x0 equal to 0, c1 is equal to 0, and t1 become 1 by omega n. Now x max is given as 0.04 meter, so we will put the values and we will find x at t equal to t1 is equal to c2 t1 e minus omega n t1 is equal to x naught dot divided by e omega n. From that we can find out x naught dot is equal to x max omega n e is equal to 0.4862 meter per second. So this is our what our gun is producing, the velocity, the recoil velocity, and we can also observe that it is less than what absorber can absorb. So we are on the safer side, like Bruce Wayne will be protected. So it will be good if I will tell you now that Bruce Wayne is only nobody but Batman, and he is this what we are designing is a Batmobile, and now you would have seen these Batmobiles in lot of movies. So actually these are the practical data which we have taken. So you have today designed a Batmobile. So this is a practical problem as such. It doesn't have it has all the components of the vibration analysis, linear vibration analysis, and congratulations, you have successfully secured a position to read this comics. So we can move on with the reading of the comics. So I am planning to put this into 2 videos. In one video up to this part I will put, and in next video I will start with the main comics. So I'm just checking if I have said everything. So I'm also writing another question, that what about cruise control mechanism, and do we have to design according to the critical damping system. In the document I will just type those questions and give an explanation, so which will be not part of the comic but a supplementary part, so I can put in the end of the comics the question asked. Okay, so this ends up the first hour. Okay, so everything is done. Now we can start with the second part.